Welcome to an example of classifications of functions such as one-one function, onto function, bijections, and invertible functions. Let A and B be two sets. Show that F defined from A cross B to B cross A such that F of the ordered pair AB is equal to ordered pair BA is a bijective function. Here we are given the domain A cross B, where A and B are two sets. A cross B is the Cartesian product of the two sets A and B, which means all possible ordered pairs that can be formed using the elements of set A as the first element and set B as the second element. Let us take some sample elements in this A cross B. A cross B consists of ordered pairs. Every element is an ordered pair. Ordered pair AM, ordered pair PQ, PH, AB, AI, etc. Some sample elements I am taking. Now, if these elements belong to set A cross B, what would have been the set A and set B? Set A is the set of all elements that are written as first element in the ordered pair. Set A, P, X, A, etc. So set A is set A, X, P, etc. The first elements of these ordered pairs form set A and second elements form set B. So set B consists of these elements M, H, I, Y, etc. Now, if this is set A and this is set B, what would be B cross A? B cross A now should be created using these elements only. If A cross B is like this, A, X, P, etc. form the set A, M, H, Y, I, Q, etc. form the set B. So the set B cross A would be set of ordered pairs MA, MX, MP, HA, HX, etc. having the elements of B as first and A as second. So the B cross A would look like this. Element MA, QP, MX, etc. Many more elements in set B cross A. Now, we are given a function. A function f is defined from set A cross B to set B cross A. Here, this set is the domain and this set is the codomain. Now, every element of the domain would be related to an element in the B cross A, that is the codomain. How? Using this rule. The rule says any element AB would be related to element BA. Element AB will be related to element BA. That means image of an ordered pair in the domain is just an ordered pair formed in the reverse way. So the image of AM or F of AM would be MA. F of PH would be element HP. It's not written here, but there must be HB here because H is available in set B and P is available in set A. So H comma P will surely be there in B cross A. Now, this rule, this function, we need to check whether it is a bijective function. A bijection is a function which is 1, 1 and onto. So we go by checking whether this is a 1, 1 function. What is a 1, 1 function? A function defined from a set to another set. Here A and B denote, the A and B stand for the domain and the codomain. A function defined from a domain to codomain is called 1, 1 function if distinct elements have distinct images. Here, let's go by taking two elements which are unequal. When we take two elements which are unequal in the domain, remember, each element is an ordered pair. PH is an element, AI is an element, etc. So, let us take x1 and x2 unequal. x1 and x2 represent elements of the domain. So, I am taking AB and PQ. AB and PQ, two unequal elements. AB is named x2 and PQ is named x1. Now, what can we say if these two ordered pairs are unequal? When do we say two ordered pairs are equal? Two ordered pairs are equal only if the first elements are equal, that is A equal to P as well as B equal to Q. Both equality should be there to have two ordered pairs equal. But for an ordered pair not to be equal to another one, it is enough to go one of them unequal. Either A is not equal to P or B is not equal to Q. Either of these inequality imply these two ordered pairs are not equal. Now it implies the ordered pair BA and QP cannot be then equal. Look, for this ordered pair BA and QP to be equal, B should have been equal to Q as well as A should have been equal to P. But one of them is gone wrong, unequal according to the previous step. So we can say these two pairs would be unequal. Now notice one thing. What is BA? BA is the image of AB under this rule. AB's image is BA. Likewise, image of PQ is QP. So, image of PQ is QP. What we have now written is actually image of x1 and image of x2 are unequal, where x1 is the ordered pair AB, x2 is the ordered pair PQ. So here, when we took two elements unequal in the domain, we are getting their images are unequal. This is what to be followed by the function to call it a 1-1 function. Whenever x1 and x2 two elements are unequal, the images should also be unequal. Yes, we are getting so. Two elements we took unequal, that clearly logically implying that the images of those two elements are also unequal. Hence, this function is a 1-1 function. It is a 1-1 function because whenever x1 and x2 are unequal, their images happen to be unequal. Now let's see whether it is an onto function. To call it an onto function, the definition says in that function, for each element taken from the codomain, this time the element need to be taken from the codomain. For each element that we take here, there must be at least one element in the domain. There exists at least one element in the domain such that the image of that element that we are getting in the domain is the original element we started here. This is the definition. To check the validity of this onto function definition, we need to check these three stages of the definition. Let's go. Assume that there is an element y in the codomain. Let y I am taking as this element MP. Y stands for any of them. I am just taking one of them. Let y is equal to ordered pair MP, which belong to B cross A, that is the codomain of our function here. If this M comma P ordered pair belong to B cross A, we can say M must be an element of B and P must be an element of A. Yes. M belongs to B and P belongs to A. That is why this ordered pair was available in B cross A. Now if M belong to B and P belong to A, the pair PM would belong to A cross B. PM. So corresponding to MP, we could find a PM in the domain. Yes, if MP is available in B cross A, there will be an ordered pair PM in the domain A cross B. Now, this definition two stages we have completed. We have taken an element in the codomain and we could get an element, a corresponding element in the domain. Now, lastly, we need to show that the image of that new element that we got is this MP itself, which means f of x is equal to y we have to prove. F of x means f of the ordered pair p comma m. So f of p comma m, according to this rule, f of p comma m is supposed to be the reverse, that is m comma p. Yes. So even the third condition is coming correct. Third stage of the definition is fulfilled. Corresponding to a y that we took in the codomain, y is a representation. For that y, the MP pair called as y, we could find a pair PM in the domain, that's the second one, second stage, such that the image of PM is this MP itself. Image of this x is this y itself. That's what we wanted to have. Hence, this given function follows the definition of onto. So we conclude that this function is an onto function. A function which is 1, 1 and onto is called a bijection. Hence, this given function from set of A cross B to set B cross A is a bijective function.